So now let me show you how to design a circular, or rather I should say, because this is a 3D structure, a cylindrical dielectric resonator. Okay. So for that, let me just hide this rectangular resonator which I have already defined. So I should hide it from this define brick material color. Sorry, this define material, define brick. I will hide it. Hide, close. Okay. So this deer is hidden now. Now I will generate a cylindrical dielectric resonator. So how shall I do? Again, I have the intention. Let me just show the speed so that we can have a this graphical maze. I have the intention to hide this annular slot at the center to be completely hidden. So the periphery is -4 to 4 in both the x as well as in the y direction. So again we will go to modeling. Now this time we will not select the brick because we are not designing a rectangular dielectric resonator, cuboidal dielectric resonator. Okay. Instead, we are defining a cylinder. So we will select this last option. See here. If you place the cursor here, the cylinder is being displayed. Click on it. Escape. Cylinder profile comes. Now you name it dr underscore cylinder. Now this orientation basically means perpendicular to the cylinder, perpendicular direction to the cylinder. This type of nomenclature we already have defined previously when we were defining the extrudes which we cut to generate the Hilbert profile. So likewise, this dielectric resonator will also have the same perpendicular direction, that is a z direction only. So we will select this z. Z is auto selected, so we will not change this selection. Now the next option is C, outer radius and inner radius. Now consider, just imagine a circle over here. Imagine a circle over here at the central portion. If the circle is like a ring shaped, suppose we are having a ring, circular ring, then that particular circular ring will have an outer radius from the center to the outer periphery and an inner radius from the center to the inner wall. I hope you can visualize the situation. Now suppose we are bringing this inner wall closer to the origin, this inner wall closer to the origin as possible. That means the inner radius will reduce. In the limiting case, when the inner wall has converged with the origin, then the inner radius is, in the limit it is minimum. So the value for that minimum inner radius will be 0 only. In that case, we will not get a ring, instead we will get a continuous circle because the inner radius has shrinked to the origin. It is a point. Outer radius remains as it is. So we will get a continuous circle. In this case, we are creating a continuous, a solid dielectric block only. We are not creating an annular block. I will show you how to create an annular block later. But for the time being, let us select that we are designing a solid dielectric block only. So the inner radius will be 0. Outer radius will be such that it hides the central slot completely. So we will select this outer radius to be a bit more than the periphery, which is -4 or 4. So it will be higher than 4. Let us select the outer radius to be, say, 6. Now the center, the origin of the entire structure is here, which is 0, 0. We have to define that origin. We have to specify that origin. So x center will be 0. Y center will be 0 only. Okay. Z min, again this dielectric block is resting on top of the patch. So the upper level of the patch, which is 1.602, will be the Z min in this case, 1.602. The height we defined to be 7 units. So we have to add 7 to it. So we will get 8.602. Okay. We don't have to do anything with the segments. We don't have to change anything with the component. Material is not PEC now. So we have to load from the material library. Again, let us select this alumina only. 99.5% lossy. 9.9 comes. It's okay. Load. It shows up here in the material. Preview. See? This circular outline you can see. Okay. Now let me tilt it. See. This is the circular dielectric. Now if I want to change the color of it, I already told you how you need to do it. DR cylinder, right click, material properties, color, select it, select the color to be yellow or anything which you want. Now let me select it to be this. Okay. Apply. Okay. It will not show up here. Select components. See. The dielectric is visible. So this is the perspective view, how it looks like. And this is the front view. Again you see the central slot is hidden. Okay, the central slot is hidden. So this is how we design a cylindrical dielectric resonator. Now I will show you how to generate some modified shapes in dielectric resonators and how to generate annular dielectric resonators.